Alright, so for example 3, I already identified the slope and the y-intercept for the first line. And I'm going to start plotting that on my graph. So the first point is the 6, I already placed that right there. And then my slope is telling me that I have to go up 3 and then 1 to the right. So if I go up 3, 1, 2, 3, 1 to the right. And I told you guys I want at least 3 points on your line. Since I don't have any more space to go up 3 units, I'm going to go backwards. So I'm going to start from the y-intercept, but instead of moving up 3, I'm going to go down 3. So 1, 2, 3. And instead of moving 1 to the right, I'm going to move 1 to the left. That way my slope is still 3 up and 1 to the right. 3 up, 1 to the right. So now I have my 3 points. I connect them with a straight line. There's my first equation. I just want to do one more example to get this line by itself. So first thing, get rid of the x's. So minus 3x, minus 3x. And I have negative y equals, remember, cannot subtract those are different, so I just copy them. Even though it looks like I'm done, I'm not, because there's still a negative right there that I have to cancel. Remember, there's a 1 right there, so I'm going to divide by negative 1. Every single term gets divided by negative 1. And so now I have y equals negative 6 divided by negative 1, that's positive 6. And negative 3 divided by negative 1, that goes to positive 3. And so now I can identify my slope and y-intercept because I have it in slope-intercept form. My slope for this line is 3 because it's next to the x. The y-intercept is 6. So if you notice, it's the exact same thing. If I were to graph this, I have the exact same equation, so I'm going to end up with the same line. Just to show you, the y-intercept is 6 right here. Up 3 over 1. So same thing, I end up with the exact same line. If I were to graph it, it's just like, now it's one line on top of the other one. So anytime I have the exact same line, same slope, same y-intercept, that is known as coinciding. Be careful, some students do not look at the y-intercept, and so they just look at the slope and they see, oh, same slope, that's parallel. No, remember, you have to look at the y-intercept. If it's the same y-intercept, then that would be coinciding, it's the same line. And if you have different y-intercepts, then that would be parallel. Okay, the last example, I worked it out already. Graph my 2 lines. I just want to point out for this one, these are known as intersecting lines. They have a different slope, but they're not opposite reciprocal slopes. So here was 1/4, here was 3/4. They're different. So those are intersecting lines. The b doesn't matter. You could have the same b or different b, it doesn't matter. All right, last 3 examples for this section. I have example 5 where they're asking me to write an equation that's parallel to the given line, and it has to go through this point right here. So for this one, since they gave me a point, I'm going to label that with x and y. And then my first step is always going to be to find m, and then I have to find b for my equation, the slope and the y-intercept. But really, I don't have to calculate the slope. All I have to do is be able to identify it from the equation that they gave me. I have to remember that parallel lines have the same slope. We just talked about it in the previous example. So for this one, parallel lines, same slope. And I know that the slope for this line is -2. Therefore, my new equation has to have the same slope of -2. You don't have to solve for it, you just have to remember same slope. The b I will have to solve, and that's where I'm going to use this slope and that point to be able to find the b. Okay, you do not use this b because you want a different line. So I'm going to plug in my numbers. For the y, I have the 4, it's right here. The m is this point right over here, that's the -2. The x value, it's up here on the point, that's 2. The b is what I'm looking for, so that stays. Now all I have to do is solve this equation. Negative 2 times 2, that's negative 4. I need b by itself, so I'm going to cancel that negative 4 by adding it to both sides. And so now 4 plus 4, that's 8. So that's my b. All I gotta do now is into this formula, I'm gonna replace the m and the b. So the m was negative 2, x, because it's the slope, always next to x. And then my b is 8, so plus 8. And so this equation and this equation, when I graph them, they will create parallel lines because they have the same slope and different y-intercepts. Okay, example 6 is very similar, but for this one, they're asking you to find an equation that's perpendicular to that same equation that I had in example 5, and that goes through the same points. But now the only thing that changed is now they're asking me for something perpendicular. So again, gotta remember, perpendicular lines have opposite reciprocal slopes. So I have to identify my slope. It's not gonna be negative 2. The original one is negative 2. It's not a fraction, so I'm gonna put a 1 underneath just so you can see this. Opposite reciprocal means that I'm going to change the sign. So it's gonna go from negative to positive. And I'm going to flip the numerator and denominator. They're going to flip. So the 1's gonna go on top, the 2's gonna go in the bottom, and this is the new slope that I need to work with because it's the opposite reciprocal. So exact same steps that I did in number 5, example 5, but now using 1/2 as my slope. So my point again is x and y. So my y is 4, my m is 1/2, my x value is 2, and the b stays. Same process. 1/2 times 2, that gives me 1. I need b by itself, so I have to get rid of the 1 by subtracting it from both sides. 4 minus 1, that's 3. So my equation, I replace the m with the 1/2 x, and the b is 3. So now, you were to graph those two equations, they would create perpendicular lines because they have opposite reciprocal slopes. And then one more example and we are done with this section. This is example 7. Here they only want me to write one equation for line AB with points A and B. So now I am going to have to calculate the slope. They're not giving me anything to start with, so I have to use the slope formula to find it. Once I have that, I'll be able to find the y-intercept the same way that I did it for example 6. So because I have 2 points, this is x1, y1, and the second one is x2, y2. And I'm just going to plug those into my formula for slope. So my y2 is right here, that's 8, minus. My y1 is right here, that's 5. And on the bottom I have x2, which is 4, minus x1, negative 8. So now I'm just subtracting. On top, 8 minus 5 gives me 3. And on the bottom, 4 minus negative 8, that gives me 12. And when you simplify, 3 divided by 12 simplifies to 1/4. So my slope is 1/4. Now to find B, exact same work that I did on example 6. So I'm going to plug in my points. And for this one, because I have 2 points, you get to choose whichever point you want. Doesn't matter, you get the same answer. So for me, I'm going to choose this point. So my y on this point is 8. My m is the 1/4 that I just solved for. My x for this point that I'm working with is 4. I'm going to solve this now. 1/4 times 4 is 1. I need b by itself, so I'm just going to subtract 1 from both sides. 8 minus 1, that's 7. So my b is 7. And so my equation now is 1/4 x plus 7. This time they're only asking me for one line.